JSHeroes. Thank you so much. It's such a privilege to be here. You know, I've heard for years about this conference from the ambassadors, from past speakers, from a number of people, and it's always been on my list. Like, I've always wanted to come here. And so this year I'm super honored. And it's so cool because it's nonprofit, it's transparent, as Alex mentioned earlier. And just looking around at all of the people in the room, I'm super hyped today to be able to share with you things that will hopefully unlock new levels of your career and give you a whole new set of skills that maybe you didn't have before. That's my hope, okay? I'm not here trying to do anything other than make new things accessible to you so that you can have the best possible career and options you have. Okay, that's my mission here today. I would love it if my slides become visible at some point, but they're optional. I did plug in, so it's not my fault, everybody. And if we can give it up for the tech team who's struggling to make this, it's the first talk. We did have some tech checks, but you know how it is, like the demo effect. Things just break when you most want them to not. Anyway, who am I? My name is Tejas. That's pronounced like contagious. Don't worry, I'm not contagious, so if you're in the front row and I spit on you, I apologize, but nothing's going to happen. I've been building on the web for over 20 years at various companies and various teams in a consulting fashion, as an employee. I've been around for a while, and I've done a lot of things that have given me a ton of opportunities to learn and grow. I've oscillated between being a manager and being an individual contributor and so on and so forth. Today, I'm a developer relations engineer at DataStax. DataStax is a company that is previously known for a database, but is wanting to be known for AI, okay? And I don't think they'll mind me saying that. It's a pivot, and that's part of my job is to help pivot through AI engineering. It's not what I'm here to talk about today. Today I want to make a statement, a hypothesis, maybe a thesis about the idea that you are or might be an AI engineer. You are or might be an AI engineer, and you might be thinking, oh gosh, it's hype chasing. It's talking about AI. Who has the counter? You know, like in Google I/O, you watch the summaries, right? Where you get this like 15-second video of them just going AI, 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 AI. And that's not what this is. In fact, this is the opposite. You see, because there's a lot of hype around it, that sometimes there's more noise than signal, if we want to talk signal to noise, okay? And so today, in our time together, in the 28 minutes I have, I want to give you some detail, some nuance around AI engineering, what it is, what it enables, to give you the skills to maybe move in that direction if you want to, because you know, the great Mark Andreessen from the VC firm A16Z, Andreessen Horowitz, said many, many years ago that software is eating the world. And it's true. Like, we used to have like clothing stores, and now we have tech companies that sell clothes, right? AI is sort of getting there at this point. It's got some type of critical mass. Everywhere you see it's AI. And sometimes it's misplaced. Like, companies will just add AI features for the sake of adding AI features, right? Regardless, it is in the zeitgeist, and it may unlock for you things that will help you thrive, okay? So before we get into it, this talk comes out of me having multiple discussions with people. As Anjana mentioned earlier, I speak at maybe too many conferences. Last year was nearly 40, right, in a 52-week year. And I speak to a lot of people, and now I talk about AI, and I ask them, hey, do you think you might be an AI, do you think you could be an AI engineer? Do you think this is something that you would be able to describe yourself as either today or in a few weeks or a few months? And the answer almost always is no, just straight up no, almost like reflexively no. And the people I'm talking to are web developers, so JavaScript, Node.js, TypeScript, React, what have you. And the answer is no. They feel like this stuff isn't accessible to them. This is not something I can play in. And then I ask, okay, why? And the answer is, well, I don't know how to do linear algebra. I don't know Python. I don't know about machine learning, hidden layers, TensorFlow. This is all too much. I didn't go to university for this. But I would bet you good money, you probably didn't even go to university for being a web developer. But it's accessible to you because of the work that a lot of the people do to make it accessible. People like Bramis and others who are here. So this is my thing. I want to make it accessible to you. So I am here to tell you that you maybe don't even need that stuff at all to be an AI engineer. And if that's a little bit too abstract, let's formally define, for the purpose of our discussion today, what an AI engineer is. And this is not my definition. I'm not an authority to define this for you, but I can show you who is. So there's a friend of mine, the great Sean Wang, host of the Latent Space podcast and also Small AI, the founder and CEO. And I want to show you this article because it is peer-reviewed, and it's very, very high quality. So this is the article. It's called The Rise of the AI Engineer by Latent Space, very popular podcast, newsletter, etc. And what you can see is it's this article that defines the role, AI engineer. And this is their thesis. And I tend to agree with this, and not just me, but the industry tends to agree with this. On the left-hand side, behind the API, you've got ML research, machine learning engineering. And this is things like training machine learning models, doing evaluations. Okay, is the output good? Is the output not good? Doing inference and doing synthetic data. All of this is behind an API. At the API boundary, after the API boundary, you have the role of the AI engineer. This is people who are using either large language models or other inference models to solve problems. Indeed, if we think about first principles, just language, what is engineering? Engineering, at least the best definition I found, is the application of technology to solve problems. You apply technology, solve problems. That's it. AI engineering, you apply AI technology to solve problems. That's it. And usually you can do this now through APIs. So I think the most popular API is probably OpenAI's HTTP API for GPT-3, 4, 4.0, whatever it may be. And so this article posits that AI engineering is distinct from machine learning engineering. You do not need linear algebra. You do not need Python. You do not need TensorFlow. You talk to an API. Okay? And this is, again, Sean Wang's Wix, but it's sort of corroborated by Andrej Karpathy, who was the former director of AI at Tesla and also the director of engineering, I believe, at OpenAI, so the company behind GPT. The sort of leader in the space who says this, and this is a direct quote, in numbers, there's probably going to be significantly more AI engineers than there are machine learning or large language model engineers. One can be quite successful in this role without what? And this is what I want you to pay attention to, without ever training anything. So this really sets a hard line between that's the data science machine learning, this is AI engineering, okay? And so I need this to be very clear, because every time I've asked someone, do you think you can be an AI engineer? The answer was always, oh, I don't know anything about machine learning or data science. And you don't need it, okay? There's an API. You talk to the API to solve problems. Again, the definition of engineering, the application of technology for problem solving. And if the technology is available over a web API, you can use it to solve problems. So what am I saying? If that's the case, if that is the case, and I sort of do some zooming in here, and this is also, by the way, a direct quote from Sean Wang. He says, this will likely be the highest demand engineering job of the decade. And we're maybe seeing that now because of the money. If you follow the money, in a relatively new field, the salaries are ridiculous, frankly. For AI engineers. And I want to make these things accessible to you so you have that career option if you so choose. Okay, so we have sort of now a working definition of AI and AI engineering. Solving problems through the use of technology, and the technology may be behind an API. Okay? If we oversimplify, just for the purpose of a discussion, some people are probably going to come after me on social media, whatever, it doesn't matter. If we just ignore it. If we oversimplify, what we can say is you could define AI engineering from a JSHeroes, like JavaScript perspective, as using the Fetch API to call an AI API, so GPT-4, Anthropic, Claude, whatever it may be. You call a large language model over HTTP. You get a response. This response could be English, it could be JSON, it could be whatever you want. And you use that response to solve some problem. So you apply technology to solve a problem. You do a fetch request, you solve a problem using a large language model that maybe you can't solve without it. This is considered AI engineering. Okay, so let me ask you again, do you think you could be an AI engineer now, right? Do you think you might already be one because you're already building things with these APIs? You just don't identify that way. You can. I want to make that very clear. There's a rising tide now, and it's important that it picks you up, that you don't miss out. Right? And I think it's important to make this accessible to you, to all of you in this room, okay? So let's talk about AI. AI, unfortunately, I was at a meetup last night, excellent women in tech meetup. It was so great, and I had the privilege of being on the panel. And there were some really good questions, and one very important question was, why do companies feel some type of pressure to put AI in everything these days? Like if you go on Notion, if you go on Slack, if you go on anything, it's like write with AI. Google Drive, write with AI. Google I/O, where's Bramus? AI, right? Why is that? And also, what is AI? Because we're now in a phase of generative AI, Gen AI, but what actually is AI? Because when I was a child, I was playing Prince of Persia, right? And like these guys would come after me with swords, you know? How did they know to find my character? I was playing Mortal Kombat and Scorpion was like, get over here. And like, was that AI? And this is true. AI is unfortunately a misused, maybe abused term today because of hype. And I want to give you the nuance here so you can understand for yourself where to use the right kind of AI and so on. So you can decipher the noise and get some signal out of it. That's the whole point of this talk. Okay, so let's talk about AI. Fundamentally, there's many, many types of AI, and it's important to know which AI we're talking about so we can have high-quality discussions and build high-quality skills, okay? So these are the types of AI. If we think back to like the early 1900s, I think it was 1906 specifically, I may get this wrong, but indeed, the early 1900s, there's a person by the name of Andrei Markov. Anyone know this name? Yeah, Andrei Markov. He invented or published a paper on what he identifies as the Markov chain. It's a chain of probabilities that is memoryless. So based on a ton of data, statistical data, knowing today's weather, I can predict tomorrow's weather. Today, Markov chains find their place in our phones. So when you're texting, you get these like suggestions for the next word. And you've probably done the challenge where like you write a word and then you hit the first suggestion repeatedly and then you generate like a nonsense sentence. That's a massive Markov chain. It's predicting the next thing based on the current thing without memory. The Markov property is the idea of memorylessness. You don't have memory, you just predict the next thing based on the current thing. Anyway, why am I telling you this? Because this has existed since like 1906. And that is considered a form of AI. That is called predictive AI. And we've had this for years. We've used it for years. This is not new, this is not hype. Previously, we also had rule-based AI. You know, Pac-Man, right? Pac-Man, the thing, the pizza that eats things. It's entirely AI-driven. Like when you eat the cherries, the ghosts turn blue and start avoiding Pac-Man, right? Those are rules that people knew that they coded into the game to create an artificially intelligent system. And that is also not, there hasn't been hype around this for years. So then why is there hype now? And that's because it's a novel type of AI called generative AI. And contrary to just making predictions via statistical models or enforcing rules as a machine, generative AI, by virtue of the transformers architecture that I believe Google invented in a paper they published, is the algorithms in the generative AI space are oriented toward novelty. What that means is combine facts A, B, C, and D, but do them in a novel way. Generate something new based on all of this input data. And that's indeed what we see with things like GPT-3 and more of these large language models. They are able to process a large number of input tokens through an enormous number of parameters. What are parameters? They're just like little dials that you can turn. And one of the smaller models, Mistral 7B, has 7 billion of them. So think of a big machine. Given an input, you have 7 billion knobs you can turn and tweak and so on to get to the next probable best generated word. So given a sentence, the quick brown fox jumps over the lazy input, and then you have 7 billion things. Turn this, turn this, turn this, turn this, turn this, turn this. Okay, dog. That's how these large language models work. They turn a bunch of little levers, and those levers are called parameters. So when you hear, for example, GPT-4 has like 600 billion parameters, just 600 billion little knobs they can tweak to find the next thing, the next generative output, okay? And so the more parameters you have, the better the inference, so the better the output. Again, this is all machine learning stuff. You don't need to know this to be an AI engineer, but I want to demystify some of these things for you because there's a lot of mystique around them now as well. So more parameters, better output, but higher cost. Yesterday, we talked a lot about the cost of AI. And indeed, in terms of money, it gets expensive, but also in terms of energy. This stuff runs on very energy-hungry GPUs, graphical processing units, and the reason it's GPUs is because they can do a lot of parallel processing. They can do highly concurrent operations. And so if you have 7 billion levers you need to turn, GPUs can do all of them in parallel and then give you an output faster than a CPU. Okay, that's why. And the more parameters you have, the more heat is produced, the worse it is for the environment. And this is why I think the future of AI, we don't have to talk about this now, is to have smaller models. Actually, we don't need such large language models for specialized use cases. Okay, but let's zero in on generative AI. And you may see this as a buzzword with just like Gen AI. This is the thing now. There's a lot of hype around it for various reasons. But I think the big reason is that it solves some real problems and use cases. Let's talk about those here in a minute. One of the big problems it solves is combining facts and ideas into language, language that we can understand. I think I've got a few demos here. I'll try not to bore you too much, but for example, I host a this is my slides, wow, behind the scenes. I host a podcast, and it's pretty long form. Actually, in a few minutes, in like 7 minutes, we're dropping an episode with one of the engineers at Slack, actually. So I'll maybe tell her about the thing. But she's absolutely brilliant, and these episodes are like an hour and a half, 2 hours, very long. And oftentimes people want like just one piece of information, you know? And so Gen AI can help with this because it can understand the entire every conversation, every word that has ever been said, and through vector or similarity search, find the right one, and then give you the answer. So I'd show you that here as a way of Gen AI solving problems. So if you go to my website, you could ask a search like, let's just tell me about work-life balance, right? And it will search across every conversation. And again, these are pretty long form, hour 42 and so on. And it's like, here, we discussed work-life balance with one of the speakers at this conference, actually, at that point in time. And then if I click on this, it will take me to exactly that point in time where I can learn more. This is a Gen AI use case, okay? There are some problems, though, with Gen AI. And this is where AI engineers are playing today. And this is where, if you want this to become accessible to you, this is important to talk about. As we know, large language models are confidently wrong. They will just tell you nonsense sometimes, and they'll do it authoritatively, like the majority party in some circles. And how can we fix that? This is where AI engineering comes to task, so to speak. And so a problem is hallucinations. That's one problem, hallucinations, seeing things that are not there. Problem number two is memory, is context size. Now, Google I/O just said they have 2 million tokens of context. That's roughly equivalent to 2 million English words. But that's not a lot, actually, right? Like, if you think about the span of your life, it's not a lot. So there's hallucinations, there's memory, and there's real time. Most of these large language models have a date where they're cut off, up to October 2021 or April, whatever. They're not like real time, like current. These three problems are the space where a lot of people are working in AI engineering today to solve them. And I want to show you in what time we have left. Unfortunately, it's 30 minutes, but I do have a 2-hour podcast episode on this, so if you want to go listen to that. What I want to show you is one technique in AI engineering that is very popular to solve all of these three problems. That is hallucinations, memory or lack of memory, and a cutoff training date. And that technique is called RAG, Retrieval Augmented Generation, where you retrieve data from some source and use it to augment the generated output of a large language model. This is literally like textbook AI engineering. And you'll notice we're not training any models. What we're doing, basically, we're querying a database, getting a bunch of results, and saying, hey, large language model, here's some context that we just got from a database just now. Use it when you speak English. RAG. There's no training, there's no data science. This is accessible to all of you if you can use a web API. I'd like to show you that here, just as a little demo. So what are the components of a RAG application, or Retrieval Augmented Generated application? You need some type of database. I work at DataStax. Again, use whatever you want. I'm not here to sell you anything. You need some type of vector database. Other alternatives are Zeta, there's Pinecone, there's Chroma, whatever you could just do Postgres with PG Vector. Find a vector database. And vector databases do similarity search. So you can search by how close is the word fruit to banana, to sausage, to whatever. And it just knows the semantic proximity of words, okay? It takes words and breaks them down into vectors. So if you look at vectors, there are these long lists of numbers, okay? And so what I want to do in our demo today is use Gen AI to predict what the next talk might be about from Ava, okay? And so what I've done is, with her consent, downloaded a bunch of posts from Ava's social media, from X, formerly Twitter. And it's all here in my vector database, okay? And we can explore how we can augment through RAG the output of a large language model with real-time information that was just posted recently. So component number one, vector database. You can use whatever you want, just have a vector driver. You insert a bunch of data into the vector database, as you can see. And now we need to retrieve this and augment the generated output from some large language model, GPT-4, whatever it may be. How might we do that? I mean, you just like fetch data from a database and give it. We'll visualize that here using a tool called Langflow that we work on at DataStax. Again, it's pre-release software. It's like version 0.1 alpha, so not telling anyone to use it. But it does help like visualize stuff. So I'll go in here, and I'll activate. Anyone use Python? You don't have to use this, but I'm activating a venv. I have to use Python now. In any case, we'll run langflow. And langflow is just a visual, it's a visualizer for how data flows through language models, okay? So we're starting langflow, it started, and here we'll just make an application. We'll make a new project, and we'll choose vector store rag. And this is why I'm using langflow. It just shows you how data flows through these AI pipelines. So what are we doing? Well, we have a chat input, and the sender name, let's just say it's Tejas, I don't know. And then we also have an OpenAI embeddings model. An embeddings model takes English or some text and turns it into a list of numbers that exist in space that are close to each other. So words like restaurant, food, meat, vegetarian would all live in the same space. And words like sports, running would live in some other space. It's all like mapped numbers in a big geographic space, okay? So we take this string, and we also take an embeddings model. Let's use embeddings 3 small. And we connect it to AstraDB search. Remember I said you need a vector database? This could be whatever you want. And in fact, Langflow has support for many, many vector stores. So you could pick anyone, Redis even, if you like rug pulls. Anyway, some of you got that. So you then choose your token. So we'll choose the API key, we'll choose the endpoint. And these are environment variables, of course. You're familiar with it as engineers. My collection name is Ava GPT from my database here. So I'm just plugging that in. And I think that's really it. And then you break the input string into chunks. So you don't, if you have a massive input string, you break it into little processable units. That's what we're doing here. And these chunks flow into a prompt. And a prompt is just a string. Prompt engineering, spoiler alert, writing English, or actually any language you want. So we have a prompt template. Given the context above that comes from our vector store, answer the question as best as possible. We can change this to whatever we want. We can say you are an AI version of Ava Ferreira. I really hope you don't mind this. I should have asked for a good, she's giving me a thumbs up. Using this context, and we'll just add context, answer this question, right? Check and save, seems to be good, and we'll connect, so the text from the chunks goes to the question, and our chat input goes to, this is the chat input, right? Yeah, the chat input goes to the context. Okay, cool. We then connect that big string to a large language model as input. Let's use GPT-4, just because we want to be fancy. And we'll turn on stream mode, so we see some answers. The temperature is how creative you want it to be, and this is important. If this number is 1, it will be like on LSD. Can I say that here at the conference? Just like see a bunch of, we don't want that. The lower the number, the more to the facts it sticks, okay? And so then finally, we get chat output. The message comes from, as you can see, the large language model, and the sender name, we could change this to fake Ava GPT, next speaker GPT, how about that? And so the problem we're solving, again, is we're taking the limitations of hallucination, a lack of memory, and a cutoff training date, and we're augmenting that with data from this data store that I just pulled from social media, okay? So let's play this in the playground. I'll open the extracted chunks, and I can be like, tell me some misconceptions of accessibility. And I will send this, and it's just a playground. Of course, I can expose this over a web API and choose whatever I want. And now if, yeah, so what you can see is as an AI version of Ava Ferreira, I can help clarify, here's a bunch of things. Accessibility is only for people, and again, this may be wrong, because the next talk has novel information and has value. But I want to just show you this rag because it pulled on this stuff from the database. This is a tweet, again, from a public source, so we're not doing anything nefarious. And it pulled on this data to augment this generation. And this solves all of those problems: a lack of memory, real-time information, and a knowledge cutoff. You can also import data into your vector store and do a similarity search and use that to augment the results. Another common case is, for example, we can make a new vector store and call it, I don't know, Wikipedia. And we'll choose a model that we know and some stuff. So I made a collection here, and I can import data into this. And it's very similar. You just fetch data from somewhere and insert it. There's also a visual builder for this. Instead of a file, we'll maybe use a web API, API request, or actually just a URL, right? And we can go to Wikipedia, n.wikipedia.org. So the Mount Edzida volcanic complex. Wow, what even is that? And so let's pull from that page, insert it into our input, and from here, if we play this now, let's give it a collection name of the one I just created, which is Wikipedia, I guess. Wikipedia. Okay, I'll play that. I'm missing some environment variables. So we'll choose the API key, the endpoint, hit play. And now it's going to ingest that URL. And again, you can do this with code, of course. We're all engineers, but I want to show this to you visually. It failed because of unauthorized URL. I think my endpoint is wrong. Something here is wrong. Or my collection just didn't create yet. These take time, usually. In any, what happened here? AstraDB API key. Okay, let's play this again. And this may fail, it may not, whatever. You can ingest this also with a fetch API. Okay, it succeeded. And now, if I go change my collection name to my bot to Wikipedia, and if I go change the name here to WikiGPT, right? What was that complex thing from Wikipedia? The Mount Edziza complex? We could just, let's clear this. Tell me about the Mount Edziza complex, right? And it's just retrieving real-time data to augment the output to solve the problems of hallucination in memory. And indeed, the Mount Edziza volcanic complex is a significant geological formation located in British Columbia. This is the stuff from Wikipedia that we just queried. And let's see if it matches. So geological formation in British Columbia, in British Columbia. So we use real-time information to augment the output and solve actual Gen AI problems. And that's a technique that everybody is using, that you can get around the inherent limitations of large language models with. This way it will not be confidently wrong, okay? And this makes AI engineering accessible to you as well. Let's wrap up with some common problems of this. And again, we're just getting started. Like, all of this is brand new, but it's a rising tide, and I hope that for some of you who want to ride it, you can now. The big problems with Gen AI are cost. So my podcast search that I showed you is really expensive because the price per million tokens is around 30 to 60 euros for the big models. But you can reduce these costs through various techniques like semantic caching, where you don't just cache the prompt output, but you cache the prompt input. And then if an input is similar to another input, you serve the generated output that you've stored somewhere. That's one technique that people are using. There's other techniques like fine-tuning, so training your own model based on GPT-3 or 4. That's something that I'm actually doing on my website as well. And the cool thing about this is it becomes more accessible. When you get your foot in the water, eventually you jump in, okay? And again, my whole goal here is to enable a new set of skills for you that you maybe don't have yet and you want. Okay, there's also latency, where these things can take time to generate. And so a way around this is also really caching. And finally, an inherent limitation is data. Some people just maybe don't have enough data to train their specialized models or enough real-time data. And there's some research being done in this direction around something they're calling synthetic data, where a large language model can generate data for you and then you curate it. Is this close to the data I want? You augment it and so on. But again, this is maybe not yet to be trusted because you can't really trust it. And maybe you shouldn't. Okay? That's a whole ethical, philosophical topic that we're not going to get into. In summary, we covered a lot of things. And I think it's really important to just break away from the hype. What was it in Google I/O? They said the word AI 121 times. They built a counter. And to get away from AI, and how can we actually add value? At the Women in Tech meetup yesterday, there was a really profound question about hype cycles, and one of the panelists, my fellow panelist Andrea, she mentioned the Gartner statistic of like oftentimes there's an event that triggers a big hype cycle and then there's disappointment and then it sort of settles. Okay, we've seen this previously, and this was contrasted yesterday with things like Web3 and cryptocurrencies and NFTs and so on. Right? There was a initial phase, there was a hype cycle, and then there was a plateau, and then there was disappointment, and now it's sort of settled. Cryptocurrencies are still used in places that are effective for where you can't rely on like banks and so on. They have their application, but they're no longer hyped. AI is in a similar place. However, the big distinction between AI and crypto that we can see is AI is already helping many, many people. Dozens and dozens. People absolutely with things like real-time language translation, with coding education. I learned Python with AI. And I think we all learn this way. So that's a huge value add, but it's also helping businesses. For example, how do I know what to recommend to people in a novel way? If it's raining outside, can I get the current weather and use that to augment output, JSON output from a large language model to affect product recommendations? Should there be more umbrellas? You know, this type of thing. It's maybe a contrived example, but the value is there for both businesses and human beings. And it's part of my desire and effort to give you these tools so you can think deeply about these things, curate the knowledge, and use it for the betterment of humanity and those around us. So what did we cover? We covered the distinction between machine learning engineering, data science, and AI engineering. We established that AI engineering is behind the API, and machine learning engineering is before the API. And so the application of technology to solve problems is where we play as engineers. We are not researchers, as far as I know. We are engineers, and we apply technology to solve problems. If you can make a network request, you can solve a problem. Let me hearken all the way back to the beginning. Are you or could you be an AI engineer? And I leave the answer up to you. Thank you so much for your time this morning.